Hey class, we're back for another week. This is chapter 8. Title of chapter 8 is Risk and Return. And so you've really learned about a lot of what we're going to talk about this week in an earlier chapter. But in that chapter, I think it was chapter 5, when you learned about interest rates and how to adjust them, how to convert them. It was all very generic and it really wasn't specific to the field of finance. And so now we're really going to start to dig in to how the field of finance uses this relationship between risk and return. And when we say risk, we're talking about, the risk that we take on any investment that we put our money into. And when we say return, we're referring to the interest rate that we demand for taking that risk, right? And so one of the quotes earlier in your textbook, and it's brought up again in this chapter, is the greater the risk, right? The greater the risk, the greater the return, right? The greater the required return should be. Okay? And this is a relationship that most of us are very familiar with because we have likely dealt with it at some point in our lives. What gets difficult, however, in finance is comparing the risk and return that two different people take. And why is that? Well, it's because we're all on different timelines. We all are making different levels of investment, some of them small, some of them large. And so, what ends up coming up, a question that often arises is well, how do I know who really got a good deal when there are two different scenarios that are really difficult to compare? And that's what the first part of this chapter begins to discuss, is how we can take different scenarios and put them into the same terms so that we can compare them. All right, so that kind of leads me to this first example here. So the first example in your chapter talks about Joe and Jane. And Joe and Jane both separately went off and made their investments, then capitalized on those investments. And as we will read in just a moment, very different types of investment, different volumes of investment, different time periods. And so it's very difficult to know who really got the best return. And so we're going to do like a two-step problem here, examples 1 and 2, to demonstrate, 1, how to calculate a return on investment, and then 2, how can I compare two different rates of return or return on investment. Okay, so first let's just read the problem, and then let's start working through this first step. So Joe bought some gold coins for $1,000 and then sold those exact same coins 4 months later for $1,200. So he bought gold. That's a commodity. He spent $1,000 on it. He held those coins for 4 months, so they were in his possession for 4 months. And at the end of those 4 months, he sold the exact same commodity for $1,200. So obviously he made a profit. Okay? And then let's look at Jane. So Jane, very, very different type of investor. She's not looking at commodities. She's looking at shares of stock. And so Jane decides that she's going to purchase 100 shares of a particular stock, right, of a stock, and she's going to pay $10 per share. She then held those for 2 years. At the end of those 2 years, she was able to sell the same 100 shares of stock for $12 per share. During that time, she also received a 50-cent per share dividend for the year that she held it. Now, that's tricky. Let me see if there's a little more explanation on my side, because that's kind of tricky. Or maybe I copied the problem wrong. Let's see. She sold those 2 years later for $12 after receiving a 50-cent per share dividend for the year. Interesting. So I'm guessing they just mean a 50-cent per share dividend for the second year, not for both years. So that's what we're going to go with. Okay. So we'll just say for the last year, just so no one gets confused. Okay, so then what is the problem asking of us? It's saying, hey, we know that both of these people made a profit, but we want to know what the percentage return is, right? So we can obviously find the dollar profit, but we want to know what the percentage return is, because once we convert to percentages, we can start to look at comparisons. All right? So there's a few things that we have to discuss before we can solve this problem. First is how do you calculate a rate of return? Like, and this is just another way of saying a ROI, right? ROI, which you should have seen in a previous chapter, or at least in your Accounting 120 course, which stands for Return on Investment. Okay, and so the easiest formula is to find the dollar profit or loss, whichever, and then divide it by the original. Whoa, I went to eraser. Sorry about that. And then divide that by the original cost. Okay, and so you might ask, okay, so how do we do that? Well, let's do these two examples, and then you'll be able to see exactly how this is done. All right, so let's look at Joe. So Joe, we'll say Joe's return. All right, so Joe's return. Well, did he make a profit or a loss? Well, he started out with $1,000 and he sold for $1,200, right? But that's not going to go up here because it only wants to know what the profit is. And so to calculate profit, we take the selling price, we subtract the investment that we originally made, and what we get is the difference of a positive $200, right? And so we're going to put 200 over 1,000, and so we're going to say 200 divided by 1,000. And so what we know is that Joe got a 20% return on his investment. All right, 20% or 0.2. Okay, so let's look at Jane's return. So what was Jane's return? All right, so this one's going to get a little more complicated. We have to do some math, don't we, to figure out how much she invested to begin with. She bought 100 shares of stock at $10 per share, right? So we're going to say 100 times 10. So she also spent $1,000. All right, and then it says 2 years later, she then sells it for $12 per share, but after receiving a 50-cent dividend for the second year. So this changes things a little bit, right? Because first we have to find what the profit was for buying at $10 and selling at $12, but then we also have to find, what that increase in ownership came, like what came from those dividends. So we need to say, okay, well, she has 100 shares of stock and she got a 50-cent dividend. So we're going to multiply that by 50 cents. This is pretty simple. That's like saying times 1/2. So, she made $50 just in dividends. Okay. And then on top of that, she also sold those 100 shares at $12 a share, right? So she sold for $1,200. So she bought for $1,000. Let me see if I can highlight this so you can see these totals. She bought for $1,000. She sold for $1,200, but not before taking $50 in profit for herself. So let's see, how much profit did she make total? Well, we have to add these two amounts here and here together. Right, so we're gonna say, let's come over here. Let's say 1,200 plus 50 minus 1,000, right? So That's the end total or the end price plus any distributions or additions to our holdings minus our original. And so what is that? Let's see. That's 1,200 plus 50 minus 1,000. And that means that she made $250 in profit. So then if we divide that by the original 1,000 that she invested, she had a 25% return. All right, so the question says calculate the dollar profit and then percentage return earned by each investor over the respective holding period. So far, this is where we are. Joe made a $200 profit. Okay. Jane made a $250 profit. And that translates to a 20% return overall for Joe and a 25% return overall for Jane. Now, some of you might say, great, let's move on to the next question. And then some of you may realize that there's an issue here. Because right now, what this problem has led us to believe is that Jane was the better investor. But what some people might have noticed, and I didn't really stress this very much yet, but I'm going to stress it now, is that Joe's return happened in 4 months, while Jane took 2 years to make the same return. And this is exactly what I was talking about at the beginning of this video, is that there are often times where we have two completely different scenarios, and so folks that we are advising will come back and say, well, how do I know who really had the better investment? Because it looks like in this case, Jane had the better investment, but did she? Did she really? Because it took her 2 years to make that return. And Joe, it only took him 4 months. And so there's a way in finance for us to deal with this issue, okay? So the way that we deal with this is we have to convert. And that's what the next part of this problem is going to ask us to do. All right, so let's just hop out of this example really quick. And then I'm going to go to example number 2. So we have now calculated the holding period return for both Joe and Jane, but it doesn't really tell us what we want to know. As investors, we want to know who had the strongest investment, okay? And there's 2 ways to do that. One of those is to find the simple annual percent rate, which is basically just taking the rate that we have and converting it into an annual rate so that we can compare the 2 rates. That's one method. The other method, and you should remember this method from chapter 5, is to find the effective annual rate. You might remember it as the ear. And if you don't remember, if we've been moving really quickly and you're like, well, gosh, I remember doing that, but I don't quite remember what that's talking about. Remember, the simple APR is the quoted or the nominal. So this is the nominal interest rate. And there's something that's very important that it does not account for. It does not account for compounding, right? And so the effective annual rate is the annual rate quoted with compounding taken into consideration, which is very important, right? We've come to learn that compounding plays a significant role in the world of finance, okay? And so that's what this next step asks us to do. It says, well, hold on a second. If Joe had a 20% return over 4 months, and Jane had a 25% over 2 years, is it correct to conclude that Jane's investment performance was better than Joe's? And tell us why. So what we're going to do now is we're going to find what the simple APR was for each of these folks. And then we're going to find what the effective annual rate was for each of these folks. And you're going to see that as we move through each step, things become more and more clear as to the performance of these two investments. Okay, so let's start with Joe. So good old Joe, he had a 20% return over 4 months. Okay, well, to find the simple APR, we take a holding period return, okay, and we divide it by N, okay, and N in this case is the number of periods that account for in a year, okay, and so there's going to be a fraction that we're going to have to work with, and I'll show you how that works. So let's keep moving forward. So Joe's simple APR is going to be equal to his holding period return, which was the 20%. Now remember, when you do algebra, you have to convert percentages to decimals. So we're going to convert it back to 0.2. And then N has to be out of a year. And so since N has to be in years, we are going to take N and we're going to say, well, he held it for 4 months out of a possible 12 months, right? And that can be simplified. That can be simplified to 1/3, right? So far, so good. So we're going to stick 1/3, which you could convert 1/3 to 0.333 if you wanted to go ahead. It's okay to use either or, that they mean the same thing. So we're going to put 0.333. It's a repeating number here. I'll show you on your calculator how you can make that happen very easily. And so now we have the numerator and the denominator, and we can calculate the simple APR that Joe had. So we're going to say, all right, we're going to say 0.2 divided by, and then what I want you to do is I want you to hit open parentheses, all right, 1 divided by 3, close parentheses. You'll see that it calculates that 0.3 repeating, and then hit equal. And what you should get is 0.6, okay, which, converts to 60%. So if someone were to ask us, okay, what was Joe's APR for his investment? He had a 60% annual percent rate, okay, 60% return on his investment. That does not include any form of compounding. That is just a simple APR. Now let's jump over and look at Jane. I'm going to have to move down a little bit. So let's look at Jane. She had a 25% return over 2 years, right? And so if we go back to the formula for the simple APR, which is the holding period return divided by N in years, right? So this one's a little bit easier because in this case, we don't have to convert in. It already is in years. So Jane's, her APR is going to be equal to 0.25 divided by 2, right? Which, if we pull our calculator out, is going to give us 0.125, which is the same thing as saying 12.5%. So now things are really starting to come into perspective, aren't they? Right? Because what do we see here? We see that if we just convert both of these rates of return or return on investment to an annual rate, just a simple annual rate, what we find is that Joe actually made a 60% return on his investment in annual terms, whereas Jane only made a 12.5% return. So all of a sudden, the tables have turned, right? And we're not even done yet. We're not even done yet because we haven't even taken compounding into consideration, because compounding is happening, right? Because any interest that you earn is thrown back into the principal, and then you earn interest on interest, right? That's what compounding does. That's what we learned back at the beginning of this class. And so the second part of this problem challenges us to also find the effective annual rate that both of these individual investors earned. So what was Joe's effective annual rate, right? And I know you'll probably have to go back in your textbook when you come across a problem and look up the formula, but luckily I have it jotted down here. So remember, the effective annual rate is 1 plus the holding period rate, right? We're going to close parentheses. We're going to raise it to 1 over n. And remember, n stands for years in this scenario, all right? Minus 1, okay? So what was Joe's effective annual rate then? You're totally going to like this. It's going to get even more extreme because of compounding. So we're going to say 1 plus 0.2. And then this gets a little tricky here. Sometimes people want to put 1/3 in here. It's not 1/3. This is where you got to remember your algebra. It's actually 1 over 1/3, right? Now, if you remember your, this is actually, I think, pre-algebra. If you remember your pre-algebra, when you divide a fraction by a fraction, because that's essentially what we're doing, you flip the second and multiply, right? So this is the same thing. This is like saying 1 over 1 times 3 over 1, which if you look at that, that actually gets very simplified very quickly. It basically just becomes 3, right? So what I can actually do is I can just erase this little section here, and I can actually just write 3, okay, minus 1. And don't forget, while we're on the topic of pre-algebra, don't forget your order of operations, PEMDAS. So we have to do the parentheses, then the exponents, then the subtraction, right? So let's do that. We're going to say 1 plus 0.2, okay? Then we're going to hit y to the x, and we're going to raise it to the third power, so 3 equals, right? So far, so good. And then we're going to say minus 1, and that's going to give us 0.728. Let me make sure that my rounding, let's see here. I want to see if my rounding is set to be 9 decimals. It is, okay. I thought there might be a few more decimals in there, but maybe it just depends on how I rounded versus how your book rounded. So let's see, second answer. So Joe's effective annual rate is 0.728. Or 72.8%. Okay, and we're not quite done, but we are almost done with this video. So now we're just going to practice this one more time. Jane's effective annual rate, 1 plus HPR raised to the 1 over n minus 1. So 1 plus 0.25 raised to the 1/2 minus 1. So let's pull that out. Let's see, 1 plus 0.25. 1.25, I'm going to raise that to the 0.5, which is the same as 1/2, equals, so far so good, minus 1, and I get 0.11. We'll just round to the third decimal here, which then converts to 11.8%. Okay, so let's summarize what we have found just by working out these two problems, and maybe I can do it over here just as a table. Let me see if I can just create a little table for us. So we have Joe, and we have Jane, and let's see, we have our return. We'll call it let's see. Make 3 rows or 3 columns. So we have 1, 2. I just want you to be able to see everything that we just did. So we have the holding period return, we have the APR, and then the effective annual rate, right? And so for Joe originally had a 20% holding period return. Jane had a 25% holding period return. So we initially thought, hey, Jane kicked Joe's behind, right? We thought that. But then we converted it to a simple APR, and what we found was that, well, hold on a second, Joe actually had a 60% APR, while Jane, she only had a 12.5% APR, right? And then we thought, well, hold on a second, we didn't even take we did not take compounding into consideration. So, now that we're finance professionals, we probably need to look at that too. And when we took compounding into effect, what we found is that Joe actually had an effective annual rate of 72.8%, right? While Jane only had an effective annual rate of 11.8%. Whoops. Go away. Go away. Sorry, guys, I don't know how to make this go away. I'm still learning this thing. There we go. 11.8%. So this is really what I want you to look at. It's just this here at the end of this video. So what we see and what this proves is that it's not as simple as what meets the eye, right? Sometimes we have to dig a little bit deeper, and when we have conversations as financial managers or financial advisors, sometimes it takes a chart just like this to explain to someone that we to whom, like an investor to whom we are advising, that hey, it may not look like you made as much money as your neighbor or your colleague or your competitor, but in reality you did, and this is how we can prove that. Now my next video is going to explain how you shouldn't take this out of context, and you shouldn't compare things that are too far-fetched from one another. But I'll leave that to the next video. I think we've definitely been on this one for a good minute. So take a break, and then the next video starts out with the next example, but also with a short overview of how not to take this out of proportion. So thanks, and we'll see you soon.